Okay, I'm going to start section 10.2 now. In 10.2, we're going to talk about the quadratic formula. Now, in 10.1, we looked at some methods for solving a quadratic equation, and those methods were factoring, and then there was extracting the square roots, or the square root properties, that means the same thing, and then completing the square. Okay? The quadratic formula states that the solutions to any quadratic equation are given by x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That's a formula that you'll want to have memorized. Okay, it's going to come up all over the place, and it's just worth knowing. Now, we'll look at some examples of using the formula in just a moment, but one of the things that we usually care about when we're doing a calculation with the quadratic formula is the discriminant of the quadratic. The resulting number that is underneath the radical in this formula is called the discriminant. Okay, the discriminants can provide some information about the solutions. Okay, so if the discriminant b squared minus 4ac happens to be a positive number, the equation is going to have two different real solutions. Remember, you always have two solutions to a quadratic. Positive discriminant means that they're going to be different real numbers. If b squared minus 4 times a times c ends up being equal to 0, the equation has a repeated solution. Okay, that can sometimes happen. If b squared minus 4 times a times c is less than 0, then the equation has two different complex solutions. Because you'd have the square root of a negative, you're going to have complex solutions. The complex solutions are non-real. Remember, any real number is a complex number. Okay, so when I say complex solutions, like it's going to be numbers involving an imaginary part, and also the numbers are conjugates of each other. So we'll look at that. Let's take a look at problem 8 here. We're going to be solving some equations using the quadratic formula. Part A, 2x squared minus 3x minus 5 equals 0. Okay, so we're going to use the quadratic formula. In using the formula, the first thing that I do is I decide, okay, what is A, what is B, what is C, and then plug in the numbers into this formula here. All right, so for this problem, looks like A is 2, B is negative 3, and C is negative 5. So I'm going to want the opposite of B, which is 3, plus or minus the square root of B squared. Negative 3 squared is 9, minus 4 times A is 2, times C is negative 5, and this is all over 2A. 2 times 2 would be 4 in the denominator. Okay, now at this point, all my information is plugged into this formula, and now it's just a matter of simplifying as far as I can go. So 9 minus a negative means that I'm adding something to 9. In this case, it's going to be 9 plus 40 would be 49. Now 49 is the discriminant, okay, what I was talking about up here. That's a positive number. So at this point, I'd want to recognize that I've got that my answers are going to be two different real solutions. Also, the square root of 49 is 7, right? So we have 3 plus or minus 7 all over 4. Okay, 3 plus 7 is 10. 10 divided by 4 would be 5 halves when you reduce. 3 minus 7 is negative 4. Negative 4 divided by 4 is negative 1. So the solutions here, notice that these are two different real numbers, okay? And now when I look at these two numbers, these aren't nasty numbers, okay? These are numbers that I could have very easily gotten by factoring. This equation does factor nicely, okay? Here would be the factorization, so that would be another option. Now I would like you to know all the methods for solving a quadratic. Okay, that's why I'm showing them to you, and you will see them on the assignments. Okay, in all, there's 4 methods: factoring, the square root property, the completing the square method, and then this one here is the fourth, the quadratic formula. Okay, let's try part B. Solve 2x squared plus 1 equals negative 4x. Okay, now before you identify what A, B, and C are, you have to first make sure that you're in this form, ax squared plus bx plus c equals 0. Now, I'm not in that form. So I want to make sure that I add 4x to both sides. Then I can say, okay, A is 2, B is 4, C is 1. And now I can start plugging in my numbers here into this formula. Okay, don't make the mistake and start identifying wrong numbers for A, B, and C if you're not initially in this form here. So we'll want the opposite of B, which is negative 4 plus or minus B squared, 4 squared is 16, minus 4 times A is 2, times C is 1, and this is all over 2A, 2 times 2 is 4 in the denominator. So now my information has been all plugged into this formula, and now I'm going to begin simplifying. Well, 16 minus 8 is 8. 8 is the discriminant. That's a positive number, so again, at this point, I would expect to have two different or real solutions once I've got this simplified. Root 8 is also going to break down for us nicely as 2 root 2. Okay, now at this point, some students will make the mistake and they'll want to cancel the negative 4 with the 4. Don't do that. You can't cancel those numbers because of the plus minus that we have going in the numerator. Okay, so I wouldn't want to make that mistake. But I can still simplify further by factoring 2 out of these two terms, and I can cancel that with part of the 4 that's in the denominator. Okay, so let me do that next. I'm going to factor 2 out from the two terms in the numerator. 2 times negative 2 is negative 4. This 2 in front of the square root of 2 has already been factored out, so I'll just have the square root of 2 remaining on that second term. 2 over 4 is 1/2. Okay, so that's going to leave me with negative 2 plus or minus root 2 all over 2. Now, just like what I mentioned with the negative 4 and the 4, how you cannot cancel those, the same thing would be true here. You can't cancel negative 2 and positive 2. Some students will want to do that. Okay, you can't cancel it because of the plus minus that we have going in the numerator. So what we see here is as simplified as we can get it. Okay, our two solutions are negative 2 plus root 2 all over 2 and then negative 2 minus root 2 all over 2. Notice that those are two different real numbers. Okay, be sure that you're simplifying as far as possible. Also be sure that you're giving the answers in exact form. Okay, again, we don't need a calculator for this, although there will be some things that we'll need a calculator for a bit later in the section. But if you're just simply solving an equation, keep it in exact form. Okay, now just an observation here. If I were to redo this problem again, factoring would not be a great option. Okay, like factoring worked over here. These numbers are not nasty looking numbers. I could have very easily gotten them by factoring. But I wouldn't want to think factoring on this problem because these nasty numbers are the factors. Okay, so actually the way that we did part B is our best option. And in general, I would also add that if you've ruled out factoring, the quadratic formula is going to be your next best option, okay, in general. I'll have some more to say about that a bit later, but keep that in mind when you're solving. If you're not actually told the method, think factoring first and then quadratic formula second if you've ruled out factoring. Really, when it comes to factoring also, if you don't see the factors in just a few seconds, then I would go on to the, plan B, which is the quadratic formula. Okay, let's take a look at part C. Of course, I'd want to add 2 to both sides first. A is 4, B is negative 2, B is negative 5, and C is 2. So I'm going to want the opposite of B, which is 5, plus or minus the square root of B squared. Negative 5 squared is 25. By the way, here's another thing to see. Notice how B squared will always be a positive. I will see students sometimes make the mistake and have this be a negative because B was a negative. Don't do that. When you square a negative, you get a positive, okay? So that will always happen where this first number here is going to be a positive number for us, okay? Negative 5 squared is 25, and then minus 4 times A is 4, times C is 2, all over 2A, 2 times 4 is 8 in the denominator. Okay, and now at this point I would just simplify. 25 minus 32 is negative 7. Negative 7 is the discriminant, so now that's a negative number, which means at this point I'd want to note that I'm going to have two different complex solutions. Okay, and I mean I could see that right away because I got the square root of a negative, like I'm going to have to do something with imaginary stuff here. The square root of negative 7 in terms of an imaginary expression is I root 7. So we're looking at 5 plus or minus I root 7 all over 8. That would be the two answers. And of course, both of these numbers are complex numbers. By the way, in 9.6, when we were talking about complex numbers and doing calculations, they had wanted you to write your answers in the form A plus B times I, or A minus B times I, okay? That was really just for that section. So from that point on, like when you're dealing with imaginary numbers, or complex numbers, you don't need to write your answers in A plus B times I form. Like you could, but you don't need to do that. Like what I have circled here works just great, okay? Here's another one. So solve the equation 9x squared equals 6x minus 1. Okay, get everything onto the left, and we're using the quadratic formula. Okay, so I'd want the opposite of b, that's 6, plus or minus the square root of b squared, negative 6 squared is 36, minus 4 times a is 9, times c is 1, all over 2a, 2 times 9 is 18. And now I'm going to simplify. 36 minus 36 is 0. Okay, whenever the discriminant is 0, you're going to have a repeated real solution. All right, so I'm going to look at 6 plus or minus 0 is 6, all over 18. 6 over 18 reduces to 1/3. Okay, so the answers here would be x equal 1/3 and x equal 1/3 again. Again, you always have two solutions with a quadratic, okay? In this case, though, we had just one number that repeated itself. Okay, so now there's a note here. The quadratic formula is the simplified result of going through the process of completing the square. Since we now know this formula, we prefer to not use the method of completing the square if given the option. In general, if you are not told the method to solve a quadratic equation, think factoring first, and if you've ruled that out, then use the quadratic formula as your next best option, okay? The completing the square method is a method that I do still want you to know, okay? But we prefer not to use that method because somebody has already done us a huge favor, and they have used that method for us. And this formula that we see is the simplified form of going through the completing the square process. So why do that again? If somebody has already done that for us, we just go to the formula, okay? So keep that in mind, that the quadratic formula is going to be your next best option if you've ruled out factoring. And what I said earlier, if you don't see the factors really in just a few seconds, then I would say go to the formula. Even if it does factor, but you're just not seeing it, I don't want to sit around and waste time, trying to think of that, doing guessing and checking. So there is another option that we could go to if we don't see the factors and very quickly. So something to keep in mind there. Okay, let's take a look at problem 9. Okay, we're going to solve this equation by using any method that we want. There's a couple of problems in the book where you're given the choice here. And now in this problem, I've got fractions. Why don't I go ahead and clear those out? Okay, if I multiply both sides by 20, 20 times 3/5, well, 20 over 5 is 4, times 3x squared would be 12x squared. And then it's going to be minus 20x plus 1/4 times 20 is 5. That's equal to 0. Okay, now if I were to try factoring, 12 has many factors. You know, it says 1 and 12, 2 and 6, 3 and 4. There's a negative in the middle and a positive at the end, so I would know that the sign's going to go minus minus, okay? But there would be some guessing and checking involved in that. So, you know, if I just don't see that in a few seconds, I would say go to the quadratic formula. The fact that 12 allows a lot of guessing and checking means that some might just directly go to the quadratic formula and not waste time guessing and checking. Okay, so let's use the quadratic formula here. We want the opposite of b, that's 20, plus or minus the square root of b squared. 20 squared, negative 20 squared is 400, minus 4 times a is 12 times c is 5, and this is all over 2a. 2 times 12 is 24. 4 times 12 times 5 would be 240. 400 minus 240 is 160. And 160, let's see, that's going to break down as, if we use 16 and 10, the square root of 16 is 4. Root 10, that'd be the leftover, that's not going to break down further. Okay, so 4 times the square root of 10, that would be the simplified form of the square root of 160. I can simplify this further by factoring out a 4 from these two terms in the numerator and then canceling that with part of the 24 that I see in the denominator. So that's what I've done next, factored 4 out front. 4 over 24 is 1/6. So you're going to have 5 plus or minus root 10 all over 6. And that would be my two solutions. Notice that I had a positive discriminant with this being 160. So I could have known at this point, I'm going to have two different real solutions, and that's exactly what happened. Okay, we'll stop right there.